Hello everyone here, this is Eason from Think Academy Singapore. Today we are going to talk about inequality. In primary school, we merely learned equation such as A equals to B, right? But in some situations, we can have A is larger than B or A is smaller than B. For this situation, we call it inequality. So to solve such kind of problems, we can get the range of certain number or certain value, and we can use the range to solve some problems. In NMOS Round 1 test, in recent years, there is always one question about inequality. Sometimes it's about calculation, sometimes it is, or more often, it's in word problems. So the two questions I put here are all 3-point questions, which means it's difficult. But its difficulty merely comes from that we are not familiar with it. So if we learn it now and be familiar with it, maybe we can be able to handle these difficult questions in this year. Okay? Now the first one comes from the 2022. It's a question 1727. So we need to find the largest integer that does not exceed these complex fractions. So first of all, can we just calculate the value directly? It can. We can solve the denominator here and divide it 1. Can have this value, right? But as you can see, it is very, very difficult. But where does this difficulty come from? It comes from the denominator here, right? They are all different. So if we want to calculate the sum, we should first of all unify the denominator, which we mean maybe 201 times 202 times 203, right? This is a terrible, terrible thing. But what if these 3 denominators are the same? And then it can be calculated very easily, right? But how can we make it same? So here comes the inequality. And we do not need to know the accurate value of this fraction, we just need to know the largest integer beneath it. So, first of all, we should learn that for 2 fractions that shares a numerator, for example 1 here, if A is larger than B, then 1 divided by A is certainly smaller than 1 divided by B. So this is the thing we all know, right? This is the inequality. And use the inequality, we can have this. These 3 fractions, of course, they are all smaller, or maybe just at least not larger than the 1/21st. Sorry, 1/201st, right? So equal, smaller, and smaller. So we can have this inequality here. And the sum of the right one, of course, is what? Is 3/201st. Okay? So now we can get that the sum of these 3 fractions is smaller than a certain value. Again, in another directions, we can have the sum of these 3 is also larger than what? If we turn them all into 203rd. Larger, larger, equal. So the sum is larger. And the right one is another value easy to calculate, is 3/203rd. So now we can have the range of the sum of the denominator. And about the original fraction here, maybe let it be A. For the same reason, A equals to 1 divided by the denominator. The denominator has its range, so A will have its range as well. Denominator is smaller than the 3/201st, so A will be, on the contrary, larger than 1 divided by 3/201st. On the other hand, denominator is larger than the 3/203rd, and A will be smaller than 3/200. And these two fractions are easy to calculate, as this will be an integer 67, and this will be 67/2. So we can get the range of A of the number we want to calculate, okay? Now the question is, what is the largest integer that does not exceed A? Now we can find that 67 here, right, is smaller than A. And A is smaller than 67/3, which is obviously smaller than 68. So A is between 67 and 68, so the integer we need to know that largest and not exceed to A will be what? Will be just 67. So the question is solved based on inequality, right? So use the equality, we can have the sum of three fractions to become a much more easier to calculate and has its range, its value, and then the answer. So this is about a calculation. And the next question, the 2021 question, is in a word problem. So this question is very similar as radial changing problems when we can use a formula to solve it. So, and there is a bag. First of all, draw 30 balls, and there are 27 red balls in here. We can write it down. And then each time, and maybe we manage each time, he draw 9 out with 5 red balls. So it tells us that he repeated the process for some times. We don't know how many times, but in the end, the bag is empty, and the total amount of red balls is at least 60% of the total number of balls, right? So let's think about it. If this is equal to 60%, how can we solve the problem? We can use an algebra, you can use a formula to do it, right? So we can just let the draw of 9 balls to be x times. Then times of 9 draws. 9 ball draws be x or be u. Okay? Then we can just calculate the total number of red balls as well as the total balls. So the total number of red balls is 27 plus 5u, and the total number is 30 plus 9u. Now here, if this is if the red ball is equal to 30% of the total number, we can have the formula as is equal to 60% times 30 plus 9u, right? So if it's equal, but here is not equal, it's at least, which is no smaller than. So to solve the problem, we can just change. If this is not equal, we can use the no smaller than to finish the formula. And we can solve it as a quotient. But beside here, we have the difference. But it does not change anything, does not influence the process if we want to solve out the u. Okay? So let's do it as we always do. First of all, on right side, we can have the 0.6 to product 30 and 9 u's, which will be 18 plus 5.4 u. Okay, now we have that on left hand there are 5 u's and right there are 5.4 u's. So we can move all the u's to the right of the, maybe not the equation, to the formula, to the inequality, right? This is an inequality. So we have this, and we calculate it out, will be 9 is not smaller than, there's a 5 here. Okay, there's a 5 here. 0.4u. And also maybe we time 5 here. Yeah. Time 5 on each side we have 45 is no smaller than 2u, and on the contrary, u is not greater than 22.5. So if it's a quotient, we have the certain value of u, but it's an inequality, so we solve out to be a range of u. So u is no larger or maybe smaller than 22.5, okay? And u is the time of draws is an integer, so the maximum value of u should be 22. And then the total value would be 30 plus 9 times 22, which will be 198 and 228. The problem is solved. In this question, we can see that the inequality shares very thing in common with the equation. So we can just solve it as the equation and find the answer we needed. But this is not at all for today. There is another very important thing to mention, that in this weekend, as next week, we'll have the NMOS Round 1 here, right? So we have last time tuition on live stream. And so on Saturday, it will be an English seminar, and Sunday, it will be a Chinese seminar. So different language, but the same contents. The content is about maybe the brief analysis of NMOS Round 1 paper, the difficulty, the knowledge point, and maybe the average point, and how much we should get to go to second round. Yeah. But more importantly, we are going to share how to arrange the 90 minutes test time, how to use the time more efficient, and how can we answer the questions to find the best strategy to get as many points as we can. So the final aim is to make every children just not behave the best, but to overcome their limitations, to get more points than they could. So this is what we want to share with you, and it's all free, okay? I will hold the Chinese version on Sunday. So now if you're interested, or if your son, your children is actually going to take the exam next Tuesday, next Tuesday, so be sure to scan the QR code and book our live streams. Okay, now that's all for today. See you tomorrow and see you at our seminar.